Forward and minimize on this thing, and then I can turn my writing tablet on. All right, go ahead.
Okay, so the first problem is the absolute value of 9x minus 11 is equal to 34.
Okay. You know how to do this?
So I'd want to add 11 to 34.
First of all, absolute value problems almost always have two solutions. Okay? So the best thing to do is to put out the two equations that are true based on this first equation. What is true is that what's inside the absolute value sign is equal to 34. That's one equation. Or what's inside the absolute value sign is equal to the negative of what was on the right side. So negative 34.
Okay.
That's how you do it. And then you solve each one individually. You solve this one, you get x equal 5. You solve this one, you get 9x equals minus 23. X equals minus 23 divided by 9.
Okay.
And both of those solutions will work. Notice that 45 minus 11 is 34. The absolute value of 34 is 34. And this solution will give you a minus 34 inside the absolute value markers. And the absolute value of minus 34 is also 34. But the secret is really to lay out those two equations. Now, having said that, there is one thing you kind of want to be a little careful with. I got trapped by this once, by like an 8th grader. So, what do I do here?
3x minus 10 is equal to negative 3, and 3x minus 10 is equal to positive 3.
Well, that's what I did. And that actually produces a couple of solutions. But if you plug them in, neither one of them works. Why? Because this always has to be a positive number. When you're taking the absolute value of something, it can never be negative, not the result. So this has to have no solution. And if you notice it right off the get-go, you'll save yourself a lot of time, effort, and probably a mistake. So that little strategy of breaking it down into two equations works just fine unless you start off with kind of a trick question. They may not give you any of these. I don't run into this very often. I swear the only time I've ever really run into it was with this 8th grader.
Okay.
So I wasn't ready for it. I didn't notice it. All right, what else you got?
Okay, so the next problem is negative 12 minus 5x is less than 23.
When you have an inequality, you pretty much solve it almost exactly the same way you solve an equation. You got to get x all by itself. The one difference is that if you ever are dividing or multiplying both sides by a negative number, you got to switch the direction of the inequality sign. So let's start this. What's your first step?
I'd add the 12 to the 23.
What's your next step?
And then I'd flip the The inequality sign.
Because you're going to divide by minus a negative.
Yeah.
Okay, so what's the answer?
X is greater than -7.
Yeah, and make sure you still do divide by the negative number. Don't forget to do that, thinking that there's only one thing to do, which is to flip the inequality sign. You still have to divide by the negative number. And that's the solution. If you were to plug in any value greater than -7, that would be a valid inequality.
Okay.
Go ahead.
Okay. Next problem is 6x is greater than or equal to 22 minus 5x, or 2x plus 1 is less than or equal to -17.
Whoa. There was an or there?
Yeah, an or. Yeah.
What's the rest of it?
2x plus 1 is less than or equal to -17.
Now, is the problem here to graph both of these and find the area, the region of solution?
It just said to solve the inequalities, so I think just solving for x.
Okay, how do you solve the first one for x?
So first I'd add 5x to 6x. And then divide 22 by 11.
Okay.
You get, 2.
So, or, now what do you do on the right side?
I would subtract 1 from the 2x plus 1. And then divide by 2.
Now, actually I don't know why I was thinking it was 2 dimensions. We only have one variable. Where it goes on the xy coordinate plane is when you have both y and x. However, we can graph this on a number line. Here's 2. There's -9. And that says closed dot, because it's greater than or equal that whole region up to infinity. And this says closed dot because it's less than or equal the -9 all the way to infinity. So this combination means this graph.
Okay.
Okay?
So then the next question is -27 is less than 2x minus 3 is less than 15.
Like that?
Yes.
Okay. When you have 3 pieces to an inequality, kind of treat it like an equation. In other words, we still want to end up with x being isolated, and it's going to end up in the middle. So that's what we have to work with. Let's get rid of everything except the x. What do I do? And when I do it, I've got to do it to both sides.
So I'd add 3 to both sides.
Okay, so that leaves 2x is less than 18 and greater than. Do I have the directions correct here? The directions on my inequality signs? Yeah. Okay. Now what can I do?
So now you can divide 2 into each equation. So x is greater than -12 and less than 9.
Yeah. Now, if I want to know where that is, there's -12, there's 9, and because it's a less than only, it's an open circle from both ends. And the area that is in our solution is that area right there, which is what that says.
Okay.
Okay? I don't know if they ask you to graph them or not, but it's helpful actually to see the graph of it, I think.
Yeah, so the next one is so it says solve the system algebraically for the common point x, y, and then add x plus y. And then it has x minus 3y is equal to negative 12. And then negative 2x plus y, 9y is equal to 45. And then it says x plus y equals blank.
Okay. Do they want you to solve for x and y, or do they want you to just solve for x plus y?
I think it just wants to solve for x plus y.
Okay. If the one thing you're allowed to do in a system of equations is add the two equations or even subtract the two equations. Okay? So it's conceivable I could have added added these two equations and ended up with minus x minus y equals some number. And then I would have my answer. And I would not have had to solve for x and y. But in this case, we do. Because there's nothing I can do to these equations to make them look like x plus y. Okay? I've got two methods of solving a system of equation. What are they?
Substitution and elimination.
Which one should we use here?
I'd say elimination.
Correct, because both equations are in standard format. Whenever they are in standard format, elimination is almost always going to be the better way to go. So, what's my first step in trying to figure out how to eliminate one of these variables?
Find the variable with the lowest common factor.
Okay, so what's your first step going to be here? This is equation number 1. That's equation number 2.
So I'd first multiply the whole of equation number 1 by positive 2.
Okay. And if I do the left side, I got to do the right side. And that turns equation number 1 into now let's draw a line through it so we don't get confused by having all these equations up here. Now what?
So then we're going to want to combine all like the two equations.
I'm going to want to add the two equations. Be specific. That's what you're doing, is adding the two equations. You have two choices. You can add equations or you can subtract equations. I cannot multiply. I cannot multiply equation 1 by equation 2 and expect to get, actually I might be able to, now that I think about it. But we never do that. We either add them or subtract them. So what am I going to do here? I'm going to add them, right?
Yeah.
Because that'll get rid of the x. And that's what we're trying to do, is eliminate a variable. So what do I get after I add them?
You get 0, and then 3y is equal to what?
21.
It's 3y equal to 21.
Yeah. So y equals 7. Now I got to solve for x.
So then we substitute the y into one or both of the equations, right?
Either one.
Okay.
Not one or both. Not into both. Actually, you could do either one, and it'll tell you what x is.
Okay.
Now, ideally, you want to use the simplest equation on the board. Which is that?
That would, I'd say x minus 3y is equal to negative
Y
12.
crossed out. So be careful about crossing stuff out. You might want to use it. Okay, so we're going to do x minus 3 times 7 equals minus 12. So x equals 9. So x plus y equals 16. 9 plus 7. And it doesn't really matter which variable you solve for first. Notice another option would have been to multiply the top by 3 instead of 2. And that would have caused the y variable to be gone when we added the two equations.
Okay.
Fine. I favor the method that uses the lowest numbers, which was your method, where we only had to multiply stuff by 2. You're going to get smaller numbers than if you go around multiplying things by 3. Notice that if I'd have multiplied it by 3, I'd have had a bigger number than minus 24.
Okay.
Now, when I said if they gave me this, do I know what x plus y is?
Yeah. 5. Yeah, 5.
5. That's the kind of thing I'm talking about, is sometimes you don't have to solve for x and y. You just have to solve for what x plus y is. If I divide everything by 2, I get x plus y equals 5.
Okay.
Now, that was not the case with that last problem. They gave us 2 equations because that's the only way we could solve it. But in rare cases, you can sometimes solve it for a combination. In other words, if you have 2 variables in one equation, you can never solve it for both those variables. But you can sometimes solve it for either an x plus y or an x minus y or an x plus 2y or whatever works.
Okay. So the next problem wants us to do this. Oh no, solve the system graphically by finding the intersection.
Okay.
Yeah. And so y is equal to 3 over 4x plus 5, and 5x plus y minus 7.
Now, when you verbalized that first one, you said 3 over 4x. It's not quite right. Well, it depends on how long you pause. But 3 over 4x could be that. And that's not what we have.
Oh, okay.
Okay? So it wasn't incorrect. It was just ambiguous. Because 3 over 4 times x is this, where the x is in the numerator, not in the denominator.
Yeah.
Okay? It always needs to be in y equal mx plus b format, means that x has to be in the numerator. Okay, so I'm going to solve this roughly by graphing it. And that's usually all you can do unless you have graphing paper, which will give you a little better resolution as to what the answer is. But I think an approximate way here is going to show you the same thing. So if I graph the first y, I'm going to start at plus 5, the y-intercept, and I'm going to apply a slope of 3/4, meaning I'm going to go up 3 and to the right 4, about there. And I'm going to connect those with a straight line. I'm going to graph the second one. I'm going to start at minus 7. Notice I'm just approximating here, which means we're not going to get a highly accurate answer. But on this one, I'm going to go up 5 and over to the right by 1. So something like that. Connect those 2 points. That is your solution. Now, what is that point? Well, if I had to guess, I would guess 4,7. Okay? Now, let's see how close we are. In other words, you see why I'm guessing 4, because that looks to me about 4, and that looks to me to be about 7. But the solution is wherever they cross. Okay, so I'm going to assume that the x-coordinate is equal to 4, the y-coordinate is equal to 7. Now, let's see how close we were. If I'm going to solve these algebraically, how would I do it?
You'd get rid of you would get the y to.
Can you use substitution or elimination?
Elimination.
No, it's not in standard format. Notice that both equations are solved for y. That makes substitution particularly easy. These y's are the same, which means this has to equal this. That's pretty easy to solve for algebraically.
Yeah.
And we're really using substitution, okay? So I'm going to move my x's to the right, my numbers to the left, so I get a 12 there. And I get 4 1/4 x, which is 17/4 x. Now I'm going to multiply both sides by 4 and divide by 17. So I get 48 divided by 17 equals x. It's a little bit less than 4. That's about 3.5. No, it's less than 3 even. It's 2 and change. So that's the correct answer. My graph, I was quite a bit off. Now, however, had I had a graph that was properly gridded, I would have been pretty close, I think. And, you know, because even applying a slope of 5 is hard the way I did it, without having it have a grid. And
Okay.
how close was I to the y? Let's see, y is equal to 5 times 48 over 17 minus 7. What is that? 240 over 17. That goes in there 14 times approximately. 14 minus 7 is 7. My y estimate was pretty good. It's 7 and change. It's not exactly 7, because that's not exactly a whole number. But so this illustrates a couple of things. First of all, graphing is not a particularly accurate method of figuring out x and y. Even if you have graphing paper and it's gridded up and you're using a ruler as a straight edge, it's still going to give, I don't know if it'll give you the exact answer like you'd want. Algebraic solution always gives it to you exactly. So I'm not a huge fan of graphing in order to find the solution. However, it is useful to know that that's the way it works. Graph each equation, where they cross is the solution.
Okay. So the next problem it wants for us to find the slope of the line containing each pair of points.
Okay.
Then find the slope of any perpendicular, any line perpendicular to these lines, and it has x is 0 and y is 9, and then x is 2 and y is 9.
And y is what?
9.
Okay. So apply your formula. What's the formula? Slope?
Slope. I can't remember off the top of my head.
Well, remember it verbally. What's the verbal formula for slope?
Point slope form.
It's rise over run.
Oh, yeah.
That's what I mean. 10 years from now, when you're out of college, you're not going to remember y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But you hopefully will still remember it's rise over run. Now, what is the rise? That's the change in the y coordinate. What is the run? That's the change in the x coordinate. So if I'm going to write it exactly, I'm going to do it this way. And you have to go in the same order. I can actually do y sub 1 minus y sub 2 as long as I do x sub 1 minus x sub 2. But I can't switch orders. I mean, I can switch them if I switch both of them. So in our problem, what is y sub 2 minus y sub 1?
So that would be 9 minus 9.
0.
That's
Divided by
0. Divided by 2.
So our slope is 0. What kind of line has a slope of 0?
A full, let's see. Yeah, straight line.
Horizontal.
Horizontal, yeah.
And in this case, that horizontal line goes through. There's one of our points. There's another point. There's the horizontal line. Now, the second part of that question is, what is the slope of the line perpendicular to that horizontal line? Well, what kind of line is perpendicular to a horizontal line?
A vertical line.
What's the slope on the vertical line?
2 over 0.
Which is what?
It can't be divided.
And undefined.
Undefined.
In other words, whenever you divide by 0, you can't divide by 0. So it's essentially infinity. Notice, that's something that's worth knowing. If I take 2 and divide it by 0.1, it's equal to 20. If I take 2 and divide it by 0.01, it's equal to 200. See what's happening? As the denominator gets closer and closer to 0, my answer gets bigger and bigger and bigger. So if I were to go all the way to 0 in the denominator, this thing goes to infinity. So when they say undefined, it's kind of the same thing as saying an infinitely steep slope.
Okay.
They don't like you using that term, infinite. The slope is not infinity. The slope is undefined.
Okay. So the next.
Yeah, okay, all right. I'll wait till you get to it. Okay.
So the next equation is it wants the same thing, and the points are negative. So x is -6, y is 1, then x is -6, and y is 8.
Okay. What kind of line is that?
That is a horizontal line. Vertical line.
What's the slope?
So the slope is 7 over 0.
So what's that slope equal?
Vertical.
Undefined and vertical line.
Yeah.
Okay, all vertical lines have an undefined slope. The line that's perpendicular to that would have what kind of a slope?
A horizontal slope, so like 0 over 7.
Just 0, yeah. In other words, anytime you have 0 in the numerator and anything but 0 in the denominator, it's 0. Okay. Must have some line. They must have some points that aren't horizontal or vertical.
Yeah, the next one is. So x is 2, y is 9, and then x is -7, and y is -6.
Okay. So now you got a non-horizontal or vertical line. So slope is what? What's the numerator going to be?
The numerator is going to be 15.
15 or -15?
Positive 15. No, wait, no.
I'll let you do that. What you're doing is you're going to do, that's actually y1 minus y2. Right? If this is y1, this is y2, the only way you get positive 15 is to take 9, subtract a -6. Okay, so that's okay. You can do that. You just have to go the same direction in the denominator.
Okay. So then the denominator, that would be -4.
No.
No, that'd be positive 8.
2 minus a -7.
Oh, yeah. So that would be a positive 9.
Yeah. I'm almost tempted to say that just always go one direction only. It's too easy. If you start mixing up your ability to start with y1 or y2, it's really easy to make a mistake. You don't want to go y1 minus y2 all over x2 minus x1. That'll give you a slope that is the negative of what your true slope would be. Okay? So to avoid ever making the mistake, I would tend to always keep it y2 minus y1. And what happens if you do that here, you get -15 in the numerator because you start with -6 minus 9. And you get -7 minus 2, you get -9 in the denominator. So your slope still comes out to be 5/3 positive. The only problem with always doing it this way is sometimes you end up having to deal with two negative signs unnecessarily. In other words, in this problem, the arithmetic is safer if you do go y1 minus y2, because that gives you a positive number in the numerator and then a positive number in the denominator. And whenever you can eliminate negative signs, you're usually better off. People make fewer mistakes when they're adding than they do when they're subtracting. Or if they're dealing with positive signs instead of negative signs, when you can. Sometimes it doesn't matter which way you go. You're going to have a negative sign in either the denominator or the numerator. I'm still inclined to think just always go one direction, and then you really can't make a mistake.
Okay.
Any other questions on this? Oh, you still need to figure out the slope of the perpendicular.
Yeah.
The way I write that is like this. I know what the slope of the line is. What's the slope of the perpendicular?
Would it just be the negative of?
You got to do two things. You got to flip the fraction and change the sign. So changing the sign makes it negative. Flipping the fraction makes it that. So that is the slope of the perpendicular. It's always the negative reciprocal. Now back when we had 0/7, and we took the negative reciprocal, you don't need a negative sign doesn't mean anything when there's a 0 involved. So it didn't really matter when we were dealing with horizontal and vertical lines. But when we're dealing with lines that have some slope that's not 0 or undefined, then when you figure out the slope of that parallel, always remember you got to do two things, not one thing.
Okay.
Okay? All right.
Okay. So the next problem is some quadratic functions.
Okay.
It wants them to be just simplified.
Okay.
So the square root of 14, and then that's in parentheses, and then parentheses square root of 21.
Like that?
Put the square root of 14 also in parentheses.
Okay.
Yeah.
So they want you to simplify. Well, there's a couple of ways you could do this. You can multiply 14 times 21, which gives you 292. So it's the square root of 292. I did that in my head, but I think that's right. No, it's 84 plus 210, so it's 294.
Yeah.
But now that becomes difficult to simplify because it's a big number. It's easier if I try to simplify both of these. Now, normally, I really wouldn't be able to simplify these because I cannot take a perfect square out of them. But if I go ahead and do it, the only way I can do it, which is to do that one like that, and to do this one like this, that actually makes the problem a lot easier. Because now I'm still multiplying four things together, and I can multiply them together in any order I want. So let's multiply that by that. What does that equal to?
49.
Square root of 49. Actually, the thing I want you to know is the square root of x times the square root of x is always x. So
Okay.
the square root of 17 times the square root of 17 equals 17. In this case, square root of 7 times square root of 7 is 7. You don't need to go all the way up to 49 and then take the square root of 49.
Yeah.
Again, keep your numbers small if you can. So I can cross that out, and add a 7. Now, what's square root of 2 times square root of 3 equal to?
Would it just be 6?
The square root of 6.
Square root of 6.
Don't leave your radical sign off. And then now that's multiplied by a 7, and I put that in front, so that's what that is. That's what square root of 294 is 7 radical 6. And they don't want a decimal value. They want the radical sign in your answer.
Okay.
I mean, I don't know that for certain, but all the stuff we've worked on lately, I can't imagine they're having you get a decimal number out of it. Because the whole difficulty of the problem is being able to do that step and that step, as opposed to just putting that into your calculator and converting it to an approximation with a decimal. At some point, using these radicals, they never want you to do that. They always want you to give a radical answer. By that, I mean I sign an answer that has the radical sign in it.
Okay.
Okay?
So then the next problem is just the square root of negative 99.
Okay. Now, we know we can't take square roots of negative numbers, right?
Yeah.
So the answer is going to have an imaginary number as part of it. There's going to be an I in there. Okay, so to figure out how to convert this to an imaginary number, what I always do is take out the negative 1 and leave the positive number. I mean, you can always separate these radicals into two things multiplied together, always. Square root of 6 is the square root of 2 times square root of 3. Things like that. Okay? And by doing this as your first step, you take all of the difficulty out of it. Now you have I, which is what that first thing is, times the square root of 99. Now, the square root of 99 can actually be simplified. What factor of 99 is a perfect square number?
9. Yeah, 9.
Okay. So I've got I times the square root of 9 times the square root of 11. With me? All I'm doing is I'm looking for factors of 99 where one of them is a perfect square number, and that number be 9. Okay, so now I've got I times 3 times square root of 11. And that's the answer, but that's not the way we usually write it. We usually put the I after everything. So the way I would write that would be this way. And the only thing you have to be careful about is to not put that I so close that nobody will be able to tell whether it's under the radical sign or not. It is not supposed to be under the radical sign. Notice I left a little bit of space. But had I done this, now you can't tell. You can't tell whether the I is by itself or if it's under the radical sign. So I'm not sure exactly why. Well, I am sure, but this convention where you put the I on the far right can be a little problematic if you don't put it far enough past the radical sign. Okay? But whenever you have that negative number, to avoid confusion, pull out the negative one first, then deal with that. That's easy enough to deal with. Just whatever square root of 99 ends up being, it's times I.
Okay. Okay, so the next problem is 15 minus 4i, and that's in parentheses, minus 9 plus 7, and that's also in parentheses. Yeah.
7i, right?
Yeah, 7i, yeah.
Okay. Adding or subtracting is really simple. You add or subtract the reals, and you add or subtract the imaginary. So what do you get when you subtract the reals?
You get 6.
What do you get when you subtract the imaginaries?
3i.
Well, here's what we have. We have minus 4i is what we're starting with. We're going to subtract a 7i. Right?
Yeah.
That is minus 11i.
Okay.
So there's a couple of ways you can look at this. I think the simplest way is the way I said it, is you subtract the reals and you subtract the imaginary. The other way is to go ahead and remove the parentheses and then combine all like terms. So I can remove the first set of parentheses without doing anything. Doesn't change anything. But when I remove the second set of parentheses, it becomes minus 9. This minus sign has to apply to that also. So it becomes minus 7i. And now you combine like terms. 15 minus 9 is 6. Minus 4i minus 7i is minus 11i.
Okay.
Either method is valid and works. The one mistake that everybody makes is they don't apply that negative sign to that term. In other words, had that been a minus 7i, well, now when I applied it, it becomes a plus 7i. So if it is a subtraction problem, make sure you subtract the reals and the imaginaries. Or an addition problem, same thing. Multiplication's a little different. You just FOIL them. Division is the only thing that's really unique when you're dividing a complex number by another complex number. If you have one of those, let's definitely do one of those.
Let's see. Does not look like we have one of those.
Okay. They may not be doing that with you. because that's a little tricky.
Yeah.
Do they have any multiplying?
Let's
Because
see.
multiplying has one little tricky aspect to it,
Yeah.
knowing that I squared is equal to minus 1.
So that's actually the next problem. So
Good. What is the next problem?
8 plus 3y times
3i?
3i, yeah. Times 6 minus 5i.
Okay, FOIL it.
So it would be, so that would be first 48x, yeah, 48 minus 40i, and then 18
plus 18.
Oh yeah, plus.
Remember, this is part of a polynomial at this point. We can't ignore plus signs. I can ignore the plus sign in front of the 48. That's the only one I can ignore. By ignoring, I mean not writing it. I have to write this plus sign. Otherwise, this would have no meaning. Okay, what's the last term?
And then minus 15i squared.
Okay, and that I squared is equal to what? If I is equal to the square root of minus 1, what is I squared equal
to? Minus 1.
Okay, so if I combine, that means that's a real number, and I'm going to be able to combine it with that real number. So what do I get when I combine those?
So you get 63.
Okay, now combine those.
Minus 22i.
And that's your answer.
Okay.
The only thing special about it is you almost always end up with this I squared somewhere. And all I squareds need to be converted to negative 1.
Okay.
Okay? In other words, turn everything you can turn into a real number, do so. I can't do anything with the 22i. That's an imaginary number. I got to leave it like that. But this I squared is not an imaginary number. That's a real number.
Okay. So the next problem wants for us to describe all the transformations with the parent function y equals x squared, which the parent function y equals x squared would go through to become the new function.
Okay.
So the first is y is equal to negative 3 over 5. And then times x minus 11 squared plus 21. And is this, did you write it as negative 3 over 5 or like negative 3/5? Because I'm not sure how I should verbalize it.
The same. It's the same regardless of where that minus sign is. If that minus sign is in the numerator or the denominator or out front, it's all the same. In other words, minus 3 over 5 equals 3 over minus 5 equals minus 3/5.
Okay.
All have the same meaning. That's why I didn't particularly differentiate where I put it.
Okay.
Okay. So we got, remember these transformations. You have 3 horizontal and 3 vertical. Okay. Horizontals are inside the function. Verticals are outside the function. So the first thing we're dealing with is that negative sign right there. What does that do? Do they want you to graph these or just describe the transformation?
Just describe the transformations.
So what does that first negative sign do? It's a reflection, right?
Yeah.
Over which axes?
Over the y-axis. Or x-axis, yeah. No, y-axis.
Which one?
I think the y-axis.
Okay, if I'm doing a vertical reflection, and it's vertical because it's outside the function, that's how you do a vertical reflection, right?
Yeah.
In other words, you would fold that vertically, and vertical means over the x-axis. If I was reflecting it horizontally, in other words, if the negative sign was inside the parentheses and in front of the x, then I would reflect it like that. I would reflect it over the y-axis.
Okay.
Okay, so the first thing, let's just list them all. 1, reflection over x. Now the 3/5. What's the 3/5 mean? First of all, is that vertical or horizontal?
That's horizontal.
Is it inside or outside the function?
Oh, it's vertical.
Okay, everything outside is vertical, everything inside is horizontal. The only horizontal thing we have is that minus 11. Everything else is vertical. The negative sign is vertical. The 3/5 is vertical. What is that called? I'm multiplying my function by 3/5. So you got 3 choices. It's either a shift, a stretch, or a shrink.
It's a shrink.
Shrink. Vertical shrink. Because there are also horizontal shrinks. This is a vertical shrink by 3/5. Okay? What that means is if I had a parabola that looked like that, a vertical shrink is going to flatten it out. It'll make it look like that. As opposed to a stretch, which makes it more vertical. Okay?
Okay.
Okay, how about that minus 11? What does that mean? Horizontal or vertical?
Horizontal.
Okay. Shift, stretch, or shrink?
Stretch.
Okay, it's being subtracted. Stretches and shrinks are multipliers. Shifts are always additions or subtractions. And the standard is x minus h. So what is h in this case?
So h is negative 11. Or, yeah, h is 11.
H is 11. It's not negative 11. It's 11. And a positive number means it's a shift to the right. So it's a horizontal shift right by 11 units. And finally, there's one last thing. Is it vertical or horizontal?
It's vertical.
Is it a stretch, shrink, or shift?
Shift.
Vertical shift. And shifts don't change the shape of the graph, ever. And it's up by 21 units. So there's the description of the 4 things that are happening with that transformation.
Okay.
That's all. Most things that can ever be is 6. Okay. If I was going to have a reflection over the y-axis, that negative sign would have to be inside the function.
Okay.
Okay. And if this was 5/3 instead of 3/5, it's a stretch, not a shrink.
Okay.
There's numbers over 1 or stretches, numbers under 1, between 0 and 1 are shrinks, unless it's horizontal, and then it's the reverse. If I've got a minus 2x in the parentheses, then that is a shrink. First of all, it's a reflection over y, and a shrink by a factor, a horizontal shrink by a factor of 2. All right. What else?
So y equals, so it's the same thing, y equals 5 times x plus 14 squared minus 9.
So the parent function is?
X squared.
Okay, and what things do we have going on working from left to right? Actually, it's not always left to right. Let me take that back. You always do the reflections first. You don't end up with the right function. Everything else can be done in whatever order you want. I like working from left to right because that's how I do math. But if there was a reflection, if there was a negative sign inside the parentheses, and I don't mean x minus 14, I mean a negative sign in front of the x, then I'm going to do that reflection over the y first before I do anything else.
Okay.
Okay? But I don't have any reflections going on here. I got no negative multipliers of x. So I can do them in whatever order I want. I'm going to go left to right. What's the 5 do?
So 5 vertically stretches it by 5.
By a factor of 5, okay. What's the next thing?
That would be x, right? Or no? 14.
Okay. So what's the 14 do?
It horizontally shifts the line by 14 units.
Which direction? And that's what you need to specify. You need to specify horizontal, the amount, and which direction.
To the right.
No. Remember what the standard is. X minus h. It's always
okay. So
in other words, I guess there's a few ways to remember this. You can remember it as plus means left, negative means right. But that kind of goes against the standard of mathematics, because typically in math, to the right means plus, to the left means minus. And so when they set up the general formula here, they use x minus h, because in this case, that would make h equal to minus 14, right? And then x minus a minus 14 would come out x plus 14. So h is actually minus 14, and minus means left. So this is horizontal shift left by 14 units. And you need to state that word, you need to state that word, that word, that word, maybe not that word, but you definitely need all the others. Okay? What's the last thing going on?
minus 9.
Got to state horizontal or vertical.
So it's a vertical.
You got to state up or down.
So it's a vertical shift down by 9.
Probably get away with that.
Okay.
Okay. And again, shifts don't change the shape of the graph. Stretches and shrinks do.
Okay.
Reflections don't really either. Think about it. They don't change the shape. Well, might turn it upside down, but they don't change the shape really.
Okay.
Let's see. That's 8 o'clock. That's probably a good place to stop. When's your final, Jonathan?
On Tuesday.
On when?
Tuesday.
Tuesday? Do you have an appointment for tomorrow, or is this going to be our last one before your final?
I think I have an appointment for tomorrow.
Yeah, I think you do too. Let me just check here before I let you go. Yeah, I've got you at 7 o'clock tomorrow night.
Okay.
Okay, I'll talk to you then.
Okay.
Have a good evening. Bye-bye.
You too.